We've already discussed benzene a little bit. We've already classified benzene as an aromatic compound. Benzene and benzene derivatives, let's say. A question I often get asked in this group is, are there other compounds besides benzene that are aromatic? The answer is yes, but I don't think we're going to be dealing with them too much. One that you might have seen, some of you got pyridine in one of your OWL questions. And pyridine is exactly like benzene, except one of the CHs has been replaced with a nitrogen. And so yes, that compound, of course, is also aromatic. And there are others besides. They're not even all six-membered rings. But I mean, some of those heterocycles are pretty important. There actually is a chapter in your book on heterocycles that I really wished I could do, but I just couldn't cram it in last semester. And I think we already cover enough. But heterocycles, meaning compounds like, well, we know what heterocycles are, but structures like that show up in biological molecules. You look at your nucleotide bases. They're chock full of aromatic rings. I mentioned also 4 of the 20 amino acids have an aromatic ring in them. We could go on. Look at most drug molecules, maybe not most, but certainly a goodly chunk of them, you'll find an aromatic ring. Whether human drugs or animal drugs, benzene and compounds like benzene just show up everywhere, both in nature and in important pharmaceuticals. So it's kind of an important set of structures to know something about in order to understand all those compounds. So we've already discussed that benzene is a resonance stabilized species. Good reminder also for the exam. Some of this is going to wind up being exam review anyway. Even if I didn't want to, which I don't mind, but some of it's going to work out that way anyway, because of course the class is cumulative, so it carries over. Remember, we draw this interesting double-headed single arrow for resonance, as opposed to the double arrow for equilibrium. But resonance is not an equilibrium, right? Remember, it's not flipping back and forth between two structures. Rather, the real structure of benzene is at all times a mixture or hybrid of those two structures. That's why they sometimes draw benzene like this, though I've done that rather terribly. I feel like I can do a little better. Sort of ashamed of myself. But that's why they sometimes draw benzene like this, with a circle in the middle. And what that circle does a very good job, man, I'm so glad it's Friday. Not exactly a circle, but we'll go with it. One thing the circle is very good at is emphasizing that we don't really have 3 double bonds in the ring. Instead, the 6 electrons that are in those 3 pi bonds, right? Each pi bond is 2 electrons, 2, 4, 6. So those 6 electrons are evenly smeared, evenly distributed around the 6 carbons of the benzene ring. If you want to think of benzene as having 6 equal bonds, 6 equal 1.5 bonds, one each between each carbon, that would not be wrong. I have no problem with your thinking of it that way. And the circle is very good at representing that. Just as a reminder, they're not localized pi bonds. It's the 6 electrons are delocalized, smeared around the ring. So that part is good. Bad thing about the circle is how many electrons are in a circle. It's not clear. So that's the bad part about it. As to which way you personally draw benzene, you can pick whichever of these so-called Kekule structures that you like, or you can draw it with the circle. I don't really care. I tend to be a circle guy. I will let you know, though, that any printed materials I make, so this would include figures on exams, this would include anything in your class notes, for instance. I use a program called Chem, which actually I think you can get your hands on for free or at least cheap. We have a site license. Chem does not make it easy for me to use this circle thing, so I will use one of these Kekule type structures, named after the person who worked out the structure of benzene, which I have some interesting, on OWL2, yeah, that doesn't surprise me, because their structure drawer is kind of like ChemDraw. I think ChemDraw is a bit better. ChemDraw has more features. For instance, I can draw a cyclohexane chair with 1 click, so that's kind of cool. and much more besides. But it's similar. It's the same type of idea. So as to which you, chem doodle, yeah, I think that's right. I think that's what it's called. I just realized, oh, thank goodness, I am recording. Ugh. I thought I wasn't for a moment. Okay, hi YouTube. Anyway, where was I? So didn't the structure of benzene come to him in a dream? Yes, that's what I heard. I'm going to, we'll get there probably next. I just want to make sure, that, that I don't skip anything else before that. Yeah, I think we're about ready to do that. Are we doing a poll today? Yep, I have one question for you guys. So you can register your attendance also, but we'll get to that later. So what about the structure of benzene? Well, for years, scientists, chemists, whatever they were back then, did not know the structure of benzene. They had worked out at first that the empirical formula, not the molecular formula, but the empirical formula of benzene was CH. They knew that benzene contained exactly as much hydrogen as it did carbon. Later, they worked out the molecular formula was C6H6. But they were not at all clear on what the structure should be. And they certainly guessed triene, things that look like cyclic trienes, but they didn't appreciate or didn't understand the idea of resonance back then. And the story is that I think it was that Mr. Kekulé, or probably Dr. Kekulé, was on a bus going somewhere and fell asleep, and he had this dream about a snake eating its own tail. And he said, "Eureka, that's it, benzene is cyclic." That's what they say. Whether there's any truth to that, I don't know, but that's what they say. But it took a little bit longer to understand that benzene is not an alkene. And honestly, if you take one thing out of today's class, I'll be happy if it's that. Benzene is not an alkene. Aromatic compounds and alkenes have completely different reactivity. One thing we'll learn probably on Wednesday is that whereas alkenes undergo addition reactions, as we're learning about, aromatic compounds do not undergo addition reactions. They undergo substitution reactions. And even then, only with pretty reactive catalysts. So, it's very different reactivity. So if you get one thing out of today's lecture, which is that benzene is not an alkene, that's not bad. I'll be happy with that. But you know, let me show you some other interesting wrong guesses at the structure of benzene that they had. Here's another C6H6. And if you work it out, that is indeed what its structure is, C6H6. That compound is known. It has been synthesized and studied, and it is not benzene. This reacts just like a normal alkene, maybe even more so because of these extremely strained fused four-membered rings, right? We talked about angle strain as a result of the bond angles being very far away from the 109.5 or 120 degrees that we would expect in single and double bonds respectively. Another interesting wrong guess. We're going to go into the third dimension this time. So I'll draw some dotted lines so you can see what's going on. Aromatic compounds, yes, that's right. Aromatic compounds do not undergo addition reactions. They undergo did I do that right? Yeah, they undergo substitution reactions, which I think we'll cover on Wednesday after the exam. I don't anticipate, I'm not eager to get quite that far today. We can take our time, we have 3 days. So still, I feel like I still did that wrong. No, I guess that's right. It's a rectangular, it's a triangular prism. I think that compound may even be called prismane, though it might not be. One could look it up. That compound is also known, it has also been prepared, and it is not benzene. It behaves very much like any other alkane, except probably a little more reactive, a little more eager to do things, especially if they can break any of those very strained bonds. And actually I thought of another one, although I'm not the first one to think of this, I know that. But here's another compound that's C6H6. And actually, speaking of exam review, Benzene is not an alkene and not an alkane. Correct. Benzene falls into the class of compounds known as aromatic compounds. So benzene is special. It's not an alkene. Benzene and related compounds, aromatic compounds, are not alkenes. Well, oh, here we go. Speaking of exam review, why don't we name that guy? Well, it is 6 carbons. There's 2 triple bonds. I conclude the triple bonds are at carbons 2 and 4, right? That's where they start. So I think we'd better call that guy 2,4 hexa diene. And it's funny looking. It really looks like you've made a spelling mistake, but I promise you that is the correct spelling. D-I-Y-N-E. 2,4 hexadiene is, I think, the best name for that compound. And that compound also exists, also certainly has been prepared, is nothing like benzene. It's just, well, it's a diene. It's a different critter. And you could maybe even come up with a couple other C6H6s, though I think those are they. But all of them have been prepared. None of them is benzene. Diene is for double bonds. Yes, that would mean there's 2 double bonds. You could have an enine. That's not unheard of. You could have one of each. Probably just made someone sad when I said that. but yeah, anyway, you're right. Good. Yeah, can't really think of anything else. I think that's enough about the structures of benzene that were wrong. Evidence that something interesting is going on with benzene can be found by looking at its reactivity. We said that alkenes can be hydrogenated. How would we name one with a double and triple bond? So the same thing. Well, you'd also have to say whether the double bond is cis or trans. And other than that, the same. Probably something like 2,4-hexene-ine or 2-hexene-4-ine or something like that. It basically follows the same rules, except that, again, you'd have to say whether the double bond is cis or trans, since it certainly would be one or the other. Anyway, benzene can be hydrogenated, just like alkenes can, but it's much more difficult. Takes very extreme conditions, very high temperatures, very high pressures. If you ever see a triangle by the reaction arrow, by the way, that just means heat. It's a shorthand for heat, and I'm even going to put 2 triangles for exceedingly a lot of heat and very high pressure. And what you call it, the catalysts that we learned about, palladium and platinum and the like, are not reactive enough for this. You generally need to go for an even more reactive metal like rhodium, RH. But be that as it may, you can hydrogenate it. It's just much more difficult, which already tells you something about the stability, the special stability of benzene. Of course, your product will be cyclohexane. The energy of this reaction, which I most certainly do not expect you to memorize, but I'm going to give it here anyway because it makes a point. Delta H of this reaction is minus 206 kilojoules per mole. The book goes into it, so I just thought I'd mention this so you understand what they're talking about. Of course, I don't expect you to memorize these numbers. That's not the point. But theory predicts delta H would be minus 356 kilojoules per mole. Oh, per mole. Dang it. Kilojoules per mole. Kilojoules per mole. Theory predicts if you calculated what you would expect the enthalpy of reaction to be, which you can do, by the way. You might even have done that in Gen Chem. Did you do a thing with like bonds formed minus bonds broken and you added up all of the bond dissociation energies? You may or may not have done that in Gen Chem. It's a way of predicting. Someone said, unfortunately, yes, I know, we're not going to do that again. But I mean, but if we did do it, this is what we'd find. It would be predicted to be minus 356 kilojoules per mole. And as such, you know, these are not close. It's off by 150 kilojoules. That's a lot. And the reason is, essentially, the 150 kilojoule per mole difference is because benzene is about 150 kilojoules per mole more stable than it would be if these were just localized double bonds. In other words, if this really were just a cyclic triene, then benzene would be a good deal less stable than it actually is. And so that's what, when you see that part in your book, that's what it's talking about. It's talking about the extra stability of benzene beyond what theory would predict. That's all they're really talking about. Certainly, I don't care if you memorize those numbers. That's not the point. But I thought I would spend a few moments talking about that, just so when you got to that part in the book, you're not completely snowed in. Let's see. Well, you know, here's what we'll do. Maybe for now, I'll get to, what are we doing in terms of time? 3:20. It actually is going pretty quickly. Let me just say one more thing. I already said some ways you can draw benzene. I said C6H6, by the way, is good. You can just draw benzene. You can just write C6H6. It'll be understood. There's really no, well, I mean, people will not think it's any one of these far less important compounds. People will know you mean benzene when you write C6H6. Another thing you might sometimes see, just to kind of warn you against it, sometimes benzene without a hydrogen, so with one of the hydrogens replaced with something else. In other words, the group C6H5 is sometimes, very often actually, abbreviated pH. That stands for phenyl, P-H-E-N-Y-L. That's what that group is called. Not phenol, phenyl. So phenyl is the name of the group C6H5. You actually can also just write C6H5. That's completely correct. Nothing wrong with that. So if you, for instance, saw PHCl, that means you've got this compound. It's chlorobenzene. Of course, it doesn't matter which of those 6 carbons I put it on. They're all the same. So that's what that means. The only thing to watch out for is pH only and always stands for C6H5. In other words, it only works for benzene with exactly one hydrogen replaced with something else. If you have a polysubstituted benzene, which scads of them exist, then you can't use pH. You have to draw the compound out. But again, mostly I'm mentioning that so when you see pH, you're not looking in the periodic table for an element pH, because you won't find it. That stands for the phenyl group. And you can use or not use either of those things as you wish. That's up to you. But I just mostly wanted to make you guys aware of that. Good. Again, I really don't see the point of, do I really want to go as far as, you know what, I do. I want to leave, let's leave nomenclature till Wednesday. So let's do, well, no, let's do our reef session. And then if anyone wants me to work out some problems or something like that, again, I can't answer what's going to be on the test. You guys know the answer by now. Everything in the book except what I've specifically said you're not responsible for. Especially the things we covered in class. Something I like to say, I might already have said this to you, please forgive me if so. One thing I like to say, you know, the process of writing an exam isn't mysterious. I don't, you know, go invoke weird prayers over some witch's cauldron or anything like that. I just think about what we talk. I get my notes out and I go, okay, what did we talk about? Let's start there. Isn't that what you would do? Pretend you're a teacher and you're going to write an exam. And so, you know, what would you put in the exam? Probably you'd start with what you talked about in class. It's no big mystery. Let's see. I already nailed the money for the answer key. Yeah, excellent. Jeez, you guys are hilarious. So just chapter 4, I will review next week. That could very well be. Occasionally there's a chapter that they don't even give me a mastery. So if it's not there, it's not there. Do be sure that you're always looking at the view that says see all assignments or view all assignments. And if you do, and there's something missing like that, don't worry, I couldn't suddenly make it appear even if I wanted to. But there are a few chapters where they don't give me a mastery. So good. Well, let's call it there. Let me instead go to PowerPoint. And let me turn this on to polling. Slideshow. Yeah, they were saying next week. So as I recall, one of those chapters didn't have a mastery. That will happen sometimes. Good. We can move on now. So my question for you is this, and I'll start in just a second. What is the expected major product of this reaction? And I would put it to you that one of those 5 structures is the correct structure of the product that you'd get. I have it covered though. Yeah, I've covered. I shouldn't be able to. Try to answer it without looking at it. Now, if I didn't have chat covering it up, we could see this, and then maybe we'd be able to see it. And if you get it done in your board, by the way, name the compound. The starting material. Well, name both. Name the starting material, name the product. Name the other ones that are wrong. I'll go out to about 2 minutes. Looks like most of you have answered. I'll even get you guys started. How about 1,1-dibromobutane? Sound good? That would, of course, be 2,2-dibromobutane. This guy would be 1,1,2,2-tetrabromobutane, 2,2,3,3 tetrabromobutane, and 2,3-dibromobutane. Those are the answers I would expect. I think those are the best answers. And of course, the starting material, 1-butene, 1-butene, because the triple bond starts in carbon 1. Good, we'll say another 10, 15 seconds or so. Anyone else? Oh, come on, can't we do 140? I guess not. Okay, so remember, alkynes do exactly the same thing as alkenes, they just do it twice. So just add bromine across it, and then add bromine across it again. So you'll wind up with a compound with 4 bromines, so A and E are out. The original would be 1-butene, yes, that's correct, and you spelled it exactly right, perfect. So it's going to 4 bromines, so I guess that is the one carbon the most left C? A good question. Answer is no. It's not necessarily the one on the left. They might turn it around the other way. They might also bend the ring around in they might also bend the ring around in a very inconvenient fashion. Owl is especially evil about that, and I am usually less evil than Owl, but I will certainly not make any promises that I will draw every compound in the most convenient way. You know, that they may not be drawn suggestively, so to speak. Anyway, as we were saying, we can rule out A, B, and E, since those all have only 2 bromines, so it must be one of these 2. And if you look where the triple bond is, it's between carbons 1 and 2, so the bromines must all be on carbons 1 and 2. So I think C is the best answer. Let's see what you guys thought. Obviously, overwhelmingly thought that. Good, so you'll get the other 8 points will eventually come from attendance. That may take me a while to get that all added up and downloaded into my, could you explain why there are 4 bromines again? Sure, let me go back to my whiteboard. Let me erase it. And this actually also counts as exam review. So better still, let's do colors. I think that's what we had, right? So if you go back to the step-by-step method I gave you for figuring out the compound, that's the major product, we're going to use an excess of bromine. Of course, it will take at least 2 mole equivalents, at least 2 molecules of bromine for every, how do you know how many bromines need to be in the chip? Well, we'll figure it out. I'll go through it using the step-by-step method that I put in the notes. After we answer, everyone asks this all the time. I wish I knew the answer. After we answer, can we leave the reef session or will it mess up the scoring since class isn't over? I don't know. I probably should know that, but I don't. But we'll be done in 10 minutes, you know. Oh, there you go. Someone's worked that out. So at first, what you're going to get, this is the final product. But remember what the rules say. You take away one of the multiple bonds, and you stick on both of those atoms, whichever halogen you're given. Actually, I really wish I'd made this red. Bromine's red anyway, just so that you have a good visual aid for it. So at first, I would expect that you would get something like this. And yes, once again, if it ever says anything on OWL is not graded, you can always trust that. I will never go in an hour and a half before it's due and change not graded to graded. Oh, yeah, I don't even think I've messed it up, though I might have, but I don't think so. I think you'll find the ones that are not graded are either what, your multimedia assignments, or if it is like a mastery, I think if you look at it, you'll find there's like 3 questions, and I don't like those being graded. It's too much pressure, you know, 3 points or 4 points per question. So you'd get this at first, and honestly, I think you'd get both cis and trans, but it doesn't matter. And then you follow the same steps again. We'll take away one of the multiple bonds. This will now be a single bond between the carbons. And on those 2 carbons, you put, again, you put whatever halogen you're given. In this case, it's bromine, so I'll put 2 more bromines on these guys. 1 on each carbon. So each carbon will wind up with 2 bromines. That's what you find you get after following the steps through. Basically, answering the question about OWL, basically, unless it says not graded, it's graded. And whatever kind of assignment it is, that may differ from week to week. Normally, the masteries and review questions ones, those are normally graded, but there may be a few exceptions. Like I said, if there's sometimes they only give me 3 or 4 questions in mastery, and I don't like it being graded then. It's too much pressure. Yeah, and sometimes there may not be a mastery, but whatever the case, please be sure you're always viewing with view all assignments. That way you'll know you're not missing any. Good. So the way I knew that the bromines went there is just by following these steps through. The bromines all have to go in carbons 1 and 2 because that's where the triple bond was. That's always going to be the case. There are no exceptions. It won't move around to other carbons. So good, that actually turned out to be some good review. I still have about 8 or 9 minutes. Let me see. Oh, but is everyone clear on this, why that's the answer? Any other questions on that? Or any other things I should go over? I don't mind ending class, but I mean, you guys have asked me for review and we have time. So. Yes. Mm-hmm. I don't really care what you use, but again, your exam is going to be multiple choice. And that's another thing, by the way. My goal is for every question to have exactly one best answer. I'm not the guy that sometimes it's one answer, sometimes it's 3. That's at least my goal. Every question should have exactly one best answer. When do you use like one? Oh, this 2-ene stuff. Well, that example doesn't work. But to fix that up a little bit, yeah, this is what I think you were asking about this, like the other names of alkenes. This is trans 2-hexene. Trans, or you could also call it E2-hexene. It's not wrong. You can always use E and Z. But cis and trans sometimes fall apart. Like if I added something else on one of those carbons, then you couldn't, one of those alkene carbons, then you couldn't use cis and trans. You'd have to use E and Z. But it's never wrong to use E and Z. You could call that E2-hexene. It's perfectly acceptable. And what they're asking about here, I think, is trans 2-hexene is kind of like the American way to name it. Most American scientists use that. Gee, would they even say trans hex 2-ene or hex trans 2-ene? I think they would say trans hex 2-ene. That's more the European way of naming. I don't really care which you use. But I can tell you that my goal is for every one of my questions to have exactly one best answer. I might screw up sometimes. I'm human. You know, we'll find that out and we'll work it out. But certainly, I don't want you to think there are any tricks. That's one of the best pieces of advice I can think about my exams in general. If you, and it's especially true of multiple choice exams, assume everything is not a trick. Take everything the most straightforward possible way. Basically, if you're reading something and it seems like there's 2 meanings, go with whatever is more straightforward and less tricky. Because I can tell you right now, I'm not going to try to trick you guys. I have no interest in that. I don't have time to trick you guys. It's a 50-minute exam, plus extra time for possible technology failures. Which reminds me, speaking of extra time, if you and I haven't spoken recently about, if you haven't reminded me recently about accommodations, disability accommodations, it wouldn't be a terrible idea to drop me an email today or this weekend, just so I can, because I set all that up in the, is there any type of extra credit for this class later on? No, I do not do extra credit just for people hoping to get a better grade. It's against department policy. And even if it weren't, already asking about extra credit, we haven't had an exam yet. There's 4 exams in the final, goodness, it's lots of time. But the thing I always like to remind people is even if it weren't against department policy, anything I offered one student, I'd have to offer everyone. And first of all, who's gonna grade all that? It's not me, I'll give you a hint. And second of all, it defeats the purpose. So no, there's ample extra credit already. Yeah, I know Chem is scary. I'm doing the best I can. And I know you guys are too. But there's already ample extra credit built in. The exams are all going to be curved to bring everything up to a reasonable place. Also remember, you only need to average 70% on OWL. That's extra credit. And most of the points in REEF are also free. It's basically mostly attendance and sometimes only attendance. So there's already some extra credit built in. It does remind me, I always produced a document that shows you how to calculate your grade at any given time, and also how to calculate what you need to get on future exams to make such and such happen. I have to make a new document because the old one was based on the weighted average system. I'm trying this new thing. I'm trying the way that's familiar to more students, which is just using a point system. So it'll be a lot easier, I think. But I do have to make that, and I'll get that done sometime after the first exam. Right now, I don't think anyone has a grade. I don't think you have a grade until that first exam is graded. Good. I wish I could do one more thing. There's 3 more minutes. What one thing should I do an example of? All right, I'll pick. Remembering functional groups. The exam is during a certain time period or all day. The first thing, it will be 15 minutes before class to 15 minutes after class. So don't come here. Which again, I guess I was going to say this earlier, but forgot. As I'm fond of saying, this is America. You can come here if you want, but don't come here. Take your exam in your whatever undisclosed location, and your secure undisclosed location. I think it will be 80 minutes. That does sound, well, let's see, 30 and 50. Yes, that sounds right. I wasted a minute. I'm sorry. Oh, what did someone say? Functional groups. Okay. Let's draw a big ugly compound. Not too big and too ugly. We have limited time. Oh, let's put one of these in 2. And then just for fun, maybe a little something like this. I could go on, but there's only 1 minute left. You had questions like this in OWL, right? They gave you some awful looking thing. And the only approach you need to take is, I have no idea what that is, and you don't need to know, but let's see what all the functional groups are. So what's this called? This is an organic derivative of ammonia. It's a nitrogen with 3 alkyl type carbons attached. Hopefully you're concluding that's an amine. If there were a carbonyl group over here, then it would be an amide, but there is none, so it's an amine. What's 2 R groups attached to a carbonyl group where both R groups are just alkyl type carbons? Begins with a K. Ketone, good. Pet peeve number 2, there is no Y in ketone. What about this guy? We've got an oxygen with 2 alkyl type carbons on either side. It's one of the organic derivatives of water. If it were OH, it'd be an alcohol, right? But it's not an alcohol. Ether, yep. And last but not least, C double bond O, OH. That's a thing for us. Carboxylic acid. So you'll notice it points in the other direction. That's what it means to know a functional group. No matter which direction it's pointing, carboxylic acid. You know, whatever side of the molecule it's on, whichever way it's pointing. This might also be abbreviated COOH or CO2H. You don't have to use those abbreviations if you don't want to. That's fully optional. But all I expect is that when you see them, you recognize them. And with that, I actually am out of time. So like I said, I'll be sure to be in front of my laptop by around noon tomorrow. Other than that, Have a great weekend. I will be communicating with you at least once more before the exam. But my experience last year was pretty good. I don't know what the kids thought, but I thought it worked out really well. Other than that, have a great weekend.